Okay, so today we're going to look at number 19. This is a problem that does integration by parts, and it feels like we're stuck in an eternal loop that we can never get out of. So to see this, I'm going to let u equal the sine of x. We know its derivative, du, is the cosine of x. I'm going to let dv equal e to the x. We know its integral is e to the x. And now I can set up my system, and I'm going to kind of drag what I'm trying to solve all the way through this problem. So in this case, e to the sine of x, or e to the x times the sine of x dx is going to equal u times v, which is e to the x sine x, minus the integral of v du, which is e to the x times the cosine of dx. When I see that integral again, I'm going to have to use integration by parts. And so in this case, I'm going to let the dv be the e to the x dx again. I can take its integral right away. I'm going to let u equal the cosine of x. I can take its derivative pretty simply, negative sine x dx. And again, I'm dragging some things through here, so I'm going to have my original problem, e to the x sine x dx. The integral of that is going to equal, and then I have my e to the x sine x minus, and then I'm going to set up my system here as u times v, so e to the x cosine x, minus the integral of v du, and the integral of v du is e to the x times negative sine x. That's going to turn that subtraction problem into addition. I can then distribute that subtraction problem, or that subtraction sign, into the bracket, and I'll get my original problem, which is the integral of e to the x sine x dx equals e to the x sine x, and then I'll have minus e to the x cosine x, and then minus the integral of e to the x sine x dx. Once I get what I originally started with, the problem from here simply becomes an algebra problem, where I just need to solve for this integral of e to the x sine x dx. So to solve for that variable, that integral, I'm going to then add the integral of e to the x sine x to both sides. And when I do that on this left side, or on the right side, I'm sorry, those things will cancel. And on the left side, I'm going to have 2 times the integral of e to the x sine x dx equals e to the x sine x minus e to the x cosine x. And so to solve for what my original problem is, I'm just going to then divide by 2. That way I get that the integral of e to the x sine x is equal to 1/2 times the quantity e to the x sine x minus e to the x cosine x. This is how we deal with things that we feel like we end up in a perpetual loop. We go through and try to get back to where we started, and then the problem literally just becomes an algebra problem that we can kind of then solve out for whatever we were looking for. Hope this helps. Good luck with your homework. The next few problems are exactly the same idea.